Okay. Well, thank you everybody for coming to the session, especially because it's a different session in which you can watch me through the internet. I promise I try to be there. I tried to fly just today in the afternoon, but the airport was closed. Today at 6 o'clock, 10 minutes in the morning, I was supposed to take off from Madrid airport. I was at 5 o'clock in the morning in the airport, and then I received the news that the airport was closed, so it was impossible for me. But I didn't want it to let you without show the new FOCA. So we've been trying to do this. I'm very happy with the technology because it's working very well. So I can watch you, you can watch me, I can listen to you, you can listen to me. So I can do all demos. Let's hope that you enjoy the talk. And I want to do a request to you, because nowadays in Spain we have hard days for our country, and we got a big problem. The big problem is not people unemployed. The worst problem in Madrid is that all good Spanish engineers are leaving our country, and probably you know some Spanish engineer. How many of you are working with a Spanish guy in a company or in a company near to you? How many of you? Yeah. Please give love to all Spanish engineers. Okay. We want them to be back, but in the meantime, give love to them. Okay.
We promise.
Well, this said, I'm going to start with the talk, with today's talk. The title is in Spanish, you know, because Spanish is better, but in English is http:// because I'm going to talk about how to use IPv6 on the internet to hack a Windows network. Of course, everybody is using IPv6 today. Probably most of the people think that they are not using IPv6, but in fact, IPv6 is activated up and running in all Windows machines since Windows Vista. If you go to the network properties, you can realize that IPv6 is activated. You know, it's in Spanish, Protocolo de Internet Protocol version 6. And the default configuration is this one that you can see on the right hand, which is obtain automatically an IPv6 address and obtain automatically DNS service. This is the default configuration, and probably in most of the companies, in most of the network, nobody is creating a special configuration for IPv6. They are in companies, they don't have a DHCP version 6 to provide IPv6 address to all networks, to all computers in the network, but in fact, IPv6 is running. If you do something very dangerous like an ipconfig in your Windows machine, you can realize that you have the local link IPv6 address. This one, the FE80::, is the local link for IPv6, and it is working. And the most important is that in the local link, I mean, in the network segment without using a router, it has the priority. So if you want to connect two computers in the same network segment, they are going to use IPv6 by default because it's the priority protocol. So if you do a route print in your Windows box, of course you are going to watch the IPv6 routing table, in which you can see the default configuration, which is, first of all, connect to the local link, which is :1/128. Then the local link for IPv6, and then the third one is the own computer, the local IPv6 address in the local computer. IPv6 is working, and if you do something very simple, you can realize the importance of this protocol in all Windows machines. In this example, we are doing something like a ping to an IPv4 address. As you can see, we are using the -a to obtain the host name. In this example, the host name is server. In the same configuration, in the same machine, without doing anything more, we can do ping server. And that we are going to obtain is that the Windows machine is going to prefer the IPv6 IPv6 protocol instead of the IPv4 protocol. This is very important because most of the security tools, security measures that sysadmin are creating in the network are based on the idea that only IPv4 is configured in the network, and it's not true. IPv6 is also configured in the network. The magic behind this simple demo is the local link manager protocol. This protocol is included in all Windows machines since Windows Vista. I mean, Windows Vista, Windows 7, and Windows 8. And the idea of this protocol is that before connecting to any computer on the network, with this protocol, the client is going to try to find all addresses related to the destination computer. So in this example, you can see how the local link manager protocol is trying to connect to, is trying to discover the server machine using IPv6 and IPv4 network, connecting, requesting the information to the broadcast, requesting the information to the DNS using IPv6 queries, using IPv4 queries, and so on. In the end, the local link manager protocol is going to obtain all ways to connect to the destination. And if in the end it's possible to connect to the server using IPv6, then the computers are going to use IPv6 to connect each other. That means that all security tools related to IPv4 attacks are not ready to discover the IPv6 attacks. One of the most important attacks in IPv4 network is the ARP spoofing, the R spoofing. R spoofing attacks are well known, and almost all networks have a special protection for R spoofing attacks. That means that or the computers have a special procedure which is detecting the R spoofing attack, or the network switches have a special protection for ARP spoofing attacks. But in IPv6, ARP is not used. Instead of the ARP table, we got the neighbors table, which is more or less the same, but based on a different protocol. As you can see, if we use the net cell interface IPv6 show neighbors, we are going to obtain a similar table as the ARP table, but based on IPv6. So in this example, we got IPv6 addresses related to MAC address. So in the end, it's more or less the same, but the big problem is that the tools anti-R spoofing are useless in this environment because we are using a different protocol. The idea is that in IPv6, we use the neighbor discovering protocol, and this protocol have 5 different packages. Messages. The first two are neighbor solicitation and neighbor advertisement, and the behavior is more or less the same like ARP. So the first one is requesting information about an IPv6 address. So neighbor solicitation is doing something like, okay, what is the MAC address of this IPv6 address? And neighbor advertisement is the response. So the guy or the computer with this IPv6 address is going to respond with, okay, I got this IPv6 address and this is my MAC address. So in this screenshot, you can see how it works in a very simple query. As you can see, we are requesting from this IPv6 address 2001:1:1, and we are sending the query to broadcast, to multicast, and the query is requesting the MAC address of the IP address 2001:1:2. So in the end, the computer with that IPv6 address, in this example 2001:1:2, is going to respond to the computer who was searching for this MAC address. This set is very similar to ARP protocol. So in the end, it's different, but the attack is more or less the same. The most common attack is the network advertisement spoofing. So in this example, we got an attacker, and the attacker has this MAC address. I mean, the MAC address ending in 4E. This computer, which is the bad guy, is spoofing this IPv6 address, the one who is ending in 40B2, and is sending a network advertisement message to this IPv6 address, the one who is ending in D3FF. So the bad guy is spoofing this IPv6 address, and the next thing that is going to do is spoofing the other guy, the other computer. So in this second package is sending a spoofed IPv6 package pretending to be the IPv6 that ends in 40B2 pretending to be the address ending in D3FF to the IPv6 address ending in 40B2. And of course, is the same guy, the attacker, who has this MAC address, the MAC address ending in 4E. So this is the most common attack, and it's very easy to do. There are a lot of tools in Backtrack to do this. We created this special tool. It's more or less like Cain. If you know Cain, it's more or less the same, but we got a lot of attacks based on IPv6. So the first network, the first demo that I'm going to do is very simple. It's just a man in the middle using network advertisement spoofing. So let me share to you my desktop. So share my desktop. So here it is.
Not yet. Yeah.
Whoop.
Now we can see it.
Could you see my desktop?
Yes.
Okay. I got two virtual machines. The one on the left is the server, and the server has an IPv4 address and an IPv6 address. So I'm going to configure the IPv4 address. Okay. With a normal IPv4 connection. So let's get into the properties and configure IPv4. So 192.178.0.1. So right now, let's clean everything from previous demos and okay. Ew, go. I need to configure the IPv4 network. Come on. Oh my God. Ew, go. So let's configure the IPv4 network. Just 1 second. Network, okay. What happened to you? Well, no worries. I cannot configure an IPv4 address, which is very bad for me. But the problem is, of course, the virtual machine. I'm not going to, it's okay. I'm going to do number 3. Okay. 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 Now activated. And now Okay, I finished to configure the IPv4. That's all. No. Well, let's do the demo. Well, as you can see in this server, I got an IPv4 network and of course the local link in the IPv6 network. If we go to the other machine, we got more or less the same, the 192.178.02. If we do ping -a 192.168.03, let's do the ping. Come on. Unavailable. What happened to you? It doesn't make sense at all. Well, I'm going to. It doesn't make. I need to activate it. Okay. Okay. Well, very hard to configure two IPv4 addresses, as you can see. Well, we got the connection. So if we do the ping again with -a modifier, we can read that the host name is server. If we do ping server, then we can see how the connection in the local segment is using IPv6 protocol. So in this environment, I'm going to open the Evil FOCA, which is running in my host machine, in my personal machine, and we got an scanner. This scanner is trying to retrieve all IPv4 addresses and all IPv6 addresses, trying to do some special tricks like figure out what IPv6 address is configured in the local link IPv6 protocol, because in most of the cases that depends from the MAC address. So in the end, Evil FOCA is recognizing the network. So in this environment, we got a lot of attacks, and the first one is the neighbor advertisement spoofing, which is quite simple. We only need to select the server, which is the one ending in 7222, and the victim or the Windows 7 machine, which is the one ending in 786. So this done, we only need to click on start, and Evil FOCA is sending the two packages needed to do the man in the middle. So in this environment, I'm going to do something very simple. I'm going to open Wireshark and just go to the client and connect to a shared folder. Let's see if it is working. Okay, and we got in the shared folder a file, a TXT file, which is password TXT, and with this text message. Very simple. But if we go to the Wireshark and we send for fail. Oh, what happened to you? Something went wrong with this car, because no, because it's using the IPv4 network instead of the IPv6. Well, something went wrong with the server, so I need to reboot the machine, because something is working bad with the IPv6 protocol, because right now it's using IPv4 instead of IPv6, and it doesn't make sense. So I'm going to do the next demo, and then I'm going to finish this one, which is the simple one. So let's stop Evil FOCA. Let's reboot this machine. Sorry for it. And let's continue with the demo. Something went bad with this machine, as you can see. Well, we don't need this machine for the second demo, so let's go to the slides and let's do the other demo. So, well, the first demo is very well known. It's very easy. It's very easy to do. The only thing that you need is that both machines are well configured with IPv6 and IPv4, as you can see with the local link IPv6 address. But the second demo is probably is the most important, because it's the main topic of this talk. The idea in IPv6 protocol is that there is a special protocol which is SLAC, that means stateless address auto configuration, that allows routers to send the default gateway to all computers in the network segment. The idea is that there are two messages which are router solicitation and router advertisement, and with these two messages a computer can request for a default gateway when it is connected to a network. So the idea is that every computer that connects to a network requests for the default gateway, sending a router solicitation message. The routers are going to send the response, which is the router advertisement. The idea of the router advertisement is that it's not necessary that previously the computer sends a router solicitation. So every router connected to the network can send router advertisement to all computers, and all computers are going to create a new IPv6 address that connects to the default gateway, and are going to configure the router sending the router advertisement package as the default gateway. This is very important because every computer that sends this router advertisement is going to be treated as a router. So in one environment like the default Windows machine configuration, all machines are waiting for routers, and routers are, of course, man-in-the-middle schemas. So the most important is that with only one package, it's possible to configure all IPv6 protocol, because by default, all Windows machines are accomplishing the DNS Autodiscovery protocol. DNS Autodiscovery protocol in IPv6 said that every computer, if no other DNS is configured in the machine, is going to use these three IPv6 address as the default DNS. So in the right moment that we send an Slack package to one computer, and that computer configures the default gateway, then we got the IPv6 configured, but without DNS. But at that moment, the DNS Autodiscovery will be up and running. This said, in an environment in which we wanted to do a man-in-the-middle attack to any computer on the network who is going to browse the internet, we don't need to do anything more, because by default, all web browsers are configured to use the IPv6 protocol when a host name is requested. This is the default configuration for Mozilla Firefox, and in it you can see how is by default is configured to false the network DNS disable IPv6. That means that by default is going to use the IPv6 protocol. In Windows, there is a strange behavior, because if you got an IPv4 protocol and an IPv6 protocol perfectly configured, I mean, with default gateway in the IPv4 protocol and default gateway in the IPv6 protocol, and you got a DNS configured in the IPv4 protocol and a new DNS configured in the IPv6 protocol, Windows is going to use by default the DNS configured in the IPv4 protocol. That means that it's supposed that DNS is only one, so it doesn't matter if you configure to the DNS using the IPv4 protocol or the IPv6 protocol. In Windows, by default, if you got the IPv4 protocol and IPv6 protocol configured, Windows is going to use the DNS version 4. If we got a Windows machine with IPv6 only configured, then the computer is going to use the DNS configured in the IPv6 protocol, but all queries are going to be requesting at type records. It doesn't make sense at all, but that's the way in which Windows is working. We need to discover why Windows is doing this, but in fact, Windows is doing that. And there is a special case in which if you have IPv6 protocol and IPv4 protocol configured only with the local link, I mean, for instance, when you configure, you connect to a Wi-Fi network and the DHCP doesn't give to you an IPv4 address, then in that case, the configuration which is going to be used is the IPv6, and all queries are going to be searching for IPv6 records. That means that if we wanted to do a man-in-the-middle in that environment, we need to do something similar to this. In this example, let's suppose that we wanted to do a man-in-the-middle attack to one computer that connects to its personal banking website. So in this example, let's suppose that the banking website is not configured with an IPv6 record, and let's suppose that the default router, this one that connects the computer to the internet, is not supporting IPv6 at all. In that environment, we can do something that allows us to create an IPv6 network between the victim and the attacker, and an IPv4 connection between the attacker and the internet. So in this example, with this, when this computer connects to internet requesting www.mypersonalbankingsite.com, we are going to retrieve the 4A's query record. In this moment, we are going to use the DNS 624 service to connect to the original DNS on the internet requesting for an IPv4 record. In that environment, we are going to retrieve the IPv4 address that our service is going to convert in an IPv6 to 4 IPv6 address. That means that for the victim, the destination website is in an IPv6 address. At that moment, the victim is going to use the default gateway in the IPv6 network to connect to the bank. And in that point, we are going to retrieve the get HTTP request over the IPv6 network and convert that IPv6 request to one IPv4 request. So, it's very simple. So we are going to retrieve the HTML page, and
we are laughing, Gemma, because there's a Java update window.
A Java?
Yeah, it's not you. It's
cool. Can you see the slides, or you have a special pop-up?
on the laptop on our side.
Okay. So, you remove it?
Yeah, there was a nice definition in the keynote about what Java means. Yeah, like yet another vulnerability announcement. So it was just fitting to the keynote.
So, continue or wait until you...
Yeah, please go on.
Continue?
Yes, please.
Okay. So, that's the idea that we are going to do with Evil FOCA. With Evil FOCA, we are going to configure the IPv6 connection, and Evil FOCA is going to do the network address translation 624 and also the DNS 624 translation. In this environment, in a man-in-the-middle schema, we need to deal with the HTTPS connection, and there are two different approaches that we can use. First one is the SSL strip approach. In this approach, the idea is that we are going to remove all S from the HTTPS links when we are sending the pages to the victim. The second approach is just to use a fake CA to create dynamically on real time fake CAs to the victim. The idea is on the second schema is that the victim is going to retrieve an alert, and then it's necessary to click on okay, I configure in this digital certificate. So far, Evil FOCA is doing only SSL trip. So let's see how it works in this environment. I'm going to share my desktop and let's do the demo, and I'm going to start the Windows 8 for later. But right now, I'm going to use only this Windows 7. So first of all, I'm going to configure IPv4 in the local link. Let's suppose that we got the 169.254.233.2 IPv4 address. Let's disable to clean everything and let's enable. Well, this is the normal configuration when you try to connect to a Wi-Fi network or whatever, and you cannot connect to the DHCP server, and then you got the local link IPv4 address. How many of you have happened this anytime in the past? How many only local link in IPv4 without DHCP? Yeah, everyone. So in this environment, we are going to do something very simple. So first of all, I'm going to use Evil FOCA, and I'm going to use the Slack attack. So I'm going to select the victim, which is this one, and just send the package. After this is done, we got, as you can see, a new IPv6 address, which had been created by the computer, by the victim, to connect to the default gateway, which is the Evil FOCA. So in this environment, we got right now IPv6 address and also the default gateway. And if we do an ipconfig/all, we got also here in the DNS server the DNS auto-configuration servers. As you can see, they are FEC0:0:0:FFFF:1, 2, and 3. So this done, if we go to my local machine and we do something very complicated like ping troopers.d, we got an IPv4 address. If we connect to the DNS and we configure an port ACE request for www.troopers.d, we got no answer because troopers.d is only working in IPv4. So in this environment, if we go and do something like ping troopers.d, here it is, we are receiving an IPv6 address. This is because the Evil FOCA is converting the IPv4 address to an IPv6 address. So this done, we only need to go to Firefox, and as you can see, we can browse the internet. We got no IPv4 connection at all because we got the local link, but everything is up and running. Let's stop this. We can go to troopers.d, and we got all the website and everything is working and everything is up and ready, and we don't have IPv4 at all, and troopers don't have IPv4 at all. If we go to the attacker machine here, we are going to, we are going to start capturing network package, and we are going to do something like very simple, like, oh, sorry, like ping W troopers D, and then we go to the Wireshark. Let's see, come on, too many packets. So, oh, sorry, it's on the cast right now. We need to test another IPv6, IPv4. So let's try it with fbi.gov, for instance. Ping. Here it is. FBI is working in IPv6, and if we go to the Wireshark, we can see how we got here that the victim, which is using IPv6, is requesting to the DNS Autodiscovery the fbi.gov in the IPv6 record. Then the computer, the attacker computer, which is this one, is requesting to the local DNS here in my network the same host name, but using the IPv4 record. And then we are doing the same with the response. When we got the response with the fbi.gov, we are going to send that convert to an IPv6 address. So you can clap. It's a very nice demo, please. Go ahead. It's amazing. You are doing a man in the middle using IPv6 with just one single click. Hey, how many of you want the Evil FOCA? No one wants the Evil FOCA? Okay. So if we go to the victim and we go to Google, we are going to, I'm going to connect to Google here in my local machine. Here, I'm going to open a new tab. Sorry, HTTP google.s, because Spanish is better. And we go to this is my local machine. And come on, Google. It works better over IPv6. So let's see. Google.com. Hey, what happened to my Google connection? Well, something with my browser right now. I don't want to break the demo. So in this example, after Google.s load the page, we are going to retrieve the HTTPS link to Gmail, but in the victim machine, we got the Gmail configured as an HTTP, not an HTTPS. So I'm going to stop here, and I'm going to open in a new record. And as you can see, it's the HTTP link, not an HTTPS. This is because Evil FOCA is removing the S of all links to do an SSL sniff. And in this example, we got a web page. I'm going to stop this capture. I'm going to start again. And the last example with this is that we got a victim and we are opening a a website that is requesting a user and password. So I'm going to use my username and my password. And let's try to log in. Okay, we failed with the password, but if we go to the capture and search from http.request method equals post, okay, we can see how it is working. As you can see, the victim is using IPv6 to send the request to the attacker, and we are sending the request to the original website. In both cases, the first one and the second one, we got the same information. So we can go to any one of them and use the follow TCP string, and in the end we are going to be able we are going to be able to read the username, schema, and the password with this FOCA rule. Okay? Very easy, very simple, just one single package. So, well, one single package and one Evil FOCA, let's say it. So, I'm going to stop this because there are a lot of traffic. Yeah, okay. Okay, so let's try the last demo because I don't like to have problems with one demo. Ooh. So let's try the first demo once again. So let's see. Well, it's opening. Let's open. Let's activate the machine maybe later. And let's configure the other machine with a normal local IPv4 address. For instance, let's stop Evil FOCA and let's configure 192.168.0.2. That's all. Let's disable and enable to have a clean network interface. So, well, here is easy to configure. Let's see in the other machine, which is not very well. So let's, okay, it's a server machine, so I think that's the problem. So let's use CMD and let's IPv config. Well, we got the 192.168.0.3. I'm going to test pin minus A 192.168.0.3. It is working, the pin. So let's see, it is working in IPv6, and if everything is okay, we only need to connect to the file server, and the protocol is going to be using IPv6. Let's see if everything is okay, but first of all, we need to use the Evil FOCA to do the man in the middle using the neighbor advertisement spoofing between the victim, which is this one, and the server, which is this one. As you can see, I'm very used to read IPv6 addresses right now. So let's start the man in the middle, and let's open the sniffer, and then if everything is okay, we go to the file server, and then we open the file. here is the password, and then we can go lot of IPv4, lot of IPv4. Hey, here it is. Yeah, we search SB, okay, and as you can see right now, the file service is running over IPv6, and of course we can do a follow TCP string, and as you can see, we can read all the talk between server and client, and of course here is the password. Okay? Hey, it is working! Well, you know, the demo effect, something happened always, but in the end, we did it. So let's go to the slides and share troopers. Here it is. Well, in the end, the IPv6 protocol is in your network. If you didn't do anything with IPv6 protocol in your network, then you have a very big problem. There are a lot of tricks that can be done with IPv6. I just wanted to show you how to create and man in the middle using IPv6 to IPv4 when you connect to the internet, but there are a lot of tricks. This one is another trick, which is a denial of service attack with the Slack protocol, because in IPv6 you can have a lot of gateways, and every time that a new router advertisement message is sent to a Windows machine, this Windows machine is going to create a new IPv6 address to connect to that router. And of course, the IPv6 networks are almost infinite, but the problem is that the memory of your Windows machine is finite. So after 1,000 router advertisement messages, you are going to have a denial of service in the Windows machine. Right now, there is no solution to this. The only response from Microsoft is just to, okay, don't let router advertisement storms attack in your network, so use some protection in the switch or in your network infrastructure to protect your Windows machines against that attacks. Well, and that's all. Just as conclusions, one thing, IPv6 is on your box, also is on your network, and the main problem is that IPv4 security tools, IPv4 security attacks are not working on the same way in the IPv6 protocol, so you need to think twice about the security of your network if you have IPv6 on it. It's not easy to remove IPv6 because after watching this talk, most of people think, okay, I'm going to disable IPv6 from all computers. That's not easy, because if you uncheck IPv6 in your Windows server, probably you will have problems, because some of the services are using only IPv6. So take care about disabling IPv6. And there are a lot of tools in IPv4 that are not working in IPv6. And there are a lot of new tools in IPv6 that are not detected at all by IPv4 protection. There are scanners, there are man-in-the-middle techniques, and so on. So that's all. Fear the evil FOCA. Fear the evil FOCA. And I would like to say thanks to people working in THC. They created a very good set of tools in that you can use it in Backtrack. You have Parasity6 that allows you to do network advertisement spoofing. You got tools for doing denial of services, tools for doing Slack attacks, and so on. And of course, a Scapy framework that allows you to create a lot of schema. And that's all. If you have any question, I'm here to try to answer them.
Gemma, thank you very much. I think applause. Yeah. As you can see, Gemma, at least we guys, we are loving Spanish people. So Are there any questions for Gemma? Not many questions. Maybe when will Evil FOCA be available to the public?
Okay. Well, Evil FOCA is going to be freeware, so don't worry. You can grab Evil FOCA very soon. Probably this Friday or next Monday, Evil FOCA is going to be released in an alpha version because we are having some problem with cookies because we have to deal with secure and HTTP only cookies. And after this issue, which is almost done, is finished, we are going to release Evil FOCA because we wanted everybody to be able to create a session on a website through our Evil FOCA. So, guys, enjoy Troopers. I would like to be with you, having dinner, have a beer for me, and hope to see you next year.
Yeah, we hope to see you again next year in person and not via WebEx session. So, Gemma, thank you very much, and
Thanks
enjoy the good weather in Spain, right?